Thank you all. We will now give a break of 10 minutes for refreshments, and we will be back here at 10 o'clock for the technical sessions. Thank you.
In its own domain, each one is a very successful case, relativity and quantum mechanics. We need an umbrella which can accommodate both of them. No. Number two is, relativity stands for Einstein's postulate that the speed of light is invariant, and it also implies that it is the highest attainable speed. Some cosmological theories and also some recent observations question the validity of this postulate. We will be very happy if we can develop the same theory or similar theory we're trying to solve. Reciprocal symmetry. It can balance like this. It can balance like this. This side's together. For this paper, number one, reciprocal symmetry, RS stands for reciprocal symmetry, as the bridge between relativity and quantum mechanics. Number two, to present RS as the substitute of Einstein's postulate. Number three, to present RS as the basis for repository every velocity u, which is x by t. We can define the slowness, which is at the reciprocal of the velocity u, which means that t equals. Physics is independent. Physics is independent of the way we describe. The principle of objectivity demands that the description in terms of velocity should be as valid as the description in terms of slowness. The objectivity of what we call nature. So it is not changed by how we look at it. So the description in terms of speed is as good as the description in terms of slowness, or vice versa. From mathematical point of view, every number has a reciprocal. Usually we represent quantities by numbers themselves, 1, 2, 3, 4, etc. Nothing stops us from representing them by the reciprocals of numbers. Instead of 1, let's say 2, we call it half. Instead of 4, 1/4, and so on. Because there's one correspondence between numbers and its reciprocal. So that is as consistent mathematically as numbers themselves. This reciprocal representation should be consistent with the representation by numbers themselves. This is the requirement. We should get a valid description if we use reciprocals of numbers instead of numbers themselves. If a velocity is represented by U form dimensionless quantity V by C, this link is not recorded. So it's V by C. We want to make dimensionless quantities so that we can further integrate with numbers. We do not want P dimension. For this, we choose a constant speed, in this case C. It will later we shall see that this speed, this C corresponds algebraically only with Einstein's C. But we are not assuming any physical meaning to it. So this corresponds or understands that there is a reciprocal relation between Planck's hypothesis and Einstein's postulate. We would like to see this a bit more in detail. So we define an energy PU as U square, which is double the usual kinetic energy. And EC will correspond again mc square. If U is less than C, which is the Einsteinian velocity, therefore it is less than C. In that case, EU will be less than or equal to EC corresponding to U less than or equal to C. The reciprocal energy when they shift the other way around, instead of less than, it will be greater than. So if we define a reciprocal energy that will be greater than this, corresponding to U star greater than C. And we did it in terms of a higher quantity which has a lower limit. When you go to gauge or do this energy E star, the gain or loss cannot be less than PC. Planck lower limit. Planck's hypothesis in Einstein's picture can invert it and by the reciprocal energy. So if Planck's energy is tau, then corresponding reciprocal energy we got without star, U only. In this case, Maxwell postulated that speed cannot be greater than c. The same thing we can say in terms of slowness or reciprocal speed. The reciprocal speed cannot be less than c, and it again becomes like Planck's statement. So for it, Einstein's postulate in Planck's picture. Discreteness. Separation between energy levels is at least greater than PC, because in Planck's picture, all energies are always greater than PC. So in that case, if we take any two energy levels, the difference is also in energy. And since energy cannot be less than PC, if it has a greater than, the difference between any two energy levels is also greater than PC. Therefore, reciprocal. If we replace the velocity u by u star and v by v star with the reciprocal velocity, our postulate is that it remains invariant. The sum is invariant. We shall try to replace Einstein's postulate by this reciprocity postulate. And if we can develop quantum mechanics or kinematic with this postulate, then we shall have achieved in developing kinematics without Einstein's postulate. With these two, we got this relation, and from these two, we get this relation. So which means, now if we put C here, instead of minus C, and reciprocal of V star is C star by C. So therefore, if V is C, C star is also C. So if we replace, which means right hand side and this side are the same, that gives us that U is equal to U star. And if U is equal to U star, then U must be C. So we proved out here from reciprocity that if addition is motion in one dimension, we shall look for an additional representation of motion which satisfies this postulate. We said that with some sort of addition, but we do not know what that function is. And we want an addition to fulfill this postulate. So we find that this is a possibility. This is an addition which fulfills this first postulate, which is we replace star, V star by U, V by U star. We get the same thing back. Simple as that. And also, we find that if the reciprocal of this quantity is also another condition which fulfills this postulate. So either this or that reciprocal multiplied C squared by this quantity. So both this addition and also this addition have both the possibilities of candidates for which fulfill this postulate. So these are two additional laws to which we have. The first one, there. This one, yes, is Einstein's law of additional velocity. So we have developed from Einstein's law of additional velocity. When we remind the law of additional velocity, which is the reciprocal of Einstein's law of additional velocity, and that satisfies the observation is that is the sum is greater than or equal to C if U star is greater than or C or V star is greater than or equal to C. Next step, what is that? The relation between continuity and discreteness. And we have seen that quantity which is continuous in its normal representation gives a discreteness and reciprocal resolution. Now we should try to see this reciprocity and the correspondence between them more easily. Correspondence between reciprocity and discreteness done by Mr. Gamma and Dr. Havada. The objective of this paper is the next paper now. What is it? In Canadian kinetics, we know V is the constant velocity, T is time, and distance is just x equal to V. We still have to define a length, like we define a c here to make speed dimensionless. Also, we should make length dimensionless. So, what is corresponding to c, we define LCT. It should be consistent with the other quantity, so this L should be equal to C multiplied by T. C is a constant, T is a constant, and L is a constant. This permits us, this is just a mathematical identity. D by C equal to logarithm of U plus D by C under root 2. D by C is tan hyperbolic of D by C. It's just a mathematical identity. And we call this quantity C, is a definition of V by C. Now, to find the distance ever, we multiply this distance V by C by this quantity T by T. So T by C multiplied by T dt. The numerator will give Vt, and the denominator will give Ct, which is L. So we get now x by L, and this simple multiplication comes here, we take the logarithm to the power, and this we write in this form. This is equal again x by L. X by L will be this, which is defined by this. So x by L will be logarithm of c, small x by L, and big V and small v are related to tan hyperbolic transformation. Similarly, this x and this small x will be correlated by a similar hyperbolic transformation. X is the distance covered in tan t by velocity v in Gaussian differentiation, and small x is the distance covered in tan t by velocity v in hyperbolic. And if we work out the definition, this small x by ct comes out to be this thing. Now we try to see what it means in Gaussian space related, especially in the special limits. We get Gaussian limit if c goes to infinity. What happens is this quantity, when c goes to infinity, and if we work out the algebraic field, in this limit, x becomes small pt. So we are again find the usual relation between velocity and distance as distance the product of c and t. And further, if c goes to infinity again, this hyperbolic transformation gives identity, and vt goes to becomes vt, which means we agree with our Canadian definition of the distance covered by time in this limit, but we have this definition of time now. And now, to correlate, we should try to go to the reciprocal space and see how it behaves when V by C is replaced by the reciprocal. Using the reciprocal velocity, V by C equal to V star by C. We start with reciprocal V, which means C by V. We define reciprocal distance Z in place of X. So here we have X, we put Z here. And in this place, instead of V by C, we put C by V. This gives us reciprocal using this transformation. This becomes V star by C into C by V. And we get the whole thing there, C by D here, and it is D by C here, if we take out this factor, minus 1 to the power of this power. So which means for even quantity, back. When it's even, this just becomes 1 and we get the whole thing back. Well, what we had before, that z is equal to x. When is z is equal to x? When it is even. When it's a odd number, it is negative and that is the reciprocal. In this case, z by x becomes x star by x, l by x, that is the reciprocal. So, we found that discrete time, t by t, with discrete or even, they give real distances. One is direct distance, the other is reciprocal distance. And when t by t is non-integral, a fraction gives a complex distance that is complex. Now, what we want to see is the correlation between discreteness and reciprocity. And we will achieve in finding that our reciprocal symmetry gives us in the reciprocity a value for the distance covered in terms of discrete quantities. Either time is discrete and also it implies that distance covered x is also discrete. It's symmetry. For this, we start with some definitions and some simple mathematical identities. This is an identity. This can be also in this form is number by 2 here, this is the delta here, the double here, the product, and we define this quantity. So again, we see that if we add I plus t to this lambda, we get this quantity. In this case, if s is even, we get the same thing back as given here. If this s is odd, we get the reciprocal. So again, if s, depending upon s, so that's even integer or odd integer, we get the same thing back or the reciprocal thing. And for non-integral, we get other values, complex values. Now we come back to Planck's relation. This quantity, if we replace this Planck's function, which is essentially the Boltzmann's function, which was used in Planck's theory, if we replace this quantity by negative reciprocal, so instead of e, we want for e, and instead of 1 minus 1, replace this, we get this quantity. And if we replace minus omega by omega prime, we get this thing. So this corresponds to this relation. Instead of minus here, is plus here, and this Boltzmann's function. And Boltzmann's function is the solution G of this differential equation, which can be written in this form. This is Boltzmann's function. We are written instead of omega, which can be decided, but essentially we are writing this function. Now, to find the reciprocal parts, we replace this differential equation by this finite difference equation. The delta plus and delta minus. Step forward and a step backward. Divide by the difference to delta. In the limit, of course, delta goes to 0, that gives us back the differential equation, but we do not want that, we want this one. If instead of this differential equation, we add this difference equation, instead of small w, we write this big W, and instead of g, we now write the function g plus minus function. This is the solution. If s is 0, we get the usual Planck case, and if s is an integer, even or odd, we get two functions. For s integer, even integer, we call it g plus. So
ask or raise any questions about this. Really? One. Okay. But as far as I understand, discreteness itself does not give you quantum mechanics. Because if you have a discrete structure that can apply either through classical physics and in many cases in quantum mechanics, the state
We can explain physical phenomena of universe. Some of the features of quantum mechanics is discrete.
Okay, yeah, I agree, but there is another point. This is not a question. This is a comment actually. As far as Deb's hypothesis is concerned, I don't think it ever tells you that there is a lower limit in energy. What it tells you that when energy is exchanged, it is in forms of lumps and chunkiness. There is chunkiness. Either you have 1 quantum, 2 or 3 or 4. But order emission. It does not tell you that energy cannot have starting values or cannot exceed starting values.
Well, thank you. As I am not a believer in Einstein's postulate, nor am I a believer in Planck's hypothesis.
Oh, okay.
Any more question? Dear audience?
About the transformation.
Dr. Shams. So, what type of rule you will follow if you use inverses that got reciprocal rules? How will you use the transformation laws?
Then we look at the afternoon quantification of velocities consistent with Lorentz-Einstein law and derivation of missing equations of special relativity.
Nobody has detected any kind of change in their experimental.
Dr. Dalu. Okay. This question is that nobody has yet experimentally verified the contraction of light in the transverse direction. So, because nobody has verified it, that is claimed by Usman. It is not.
Include square. Okay. What is the dimension? What is the effect of velocity? So what is originally said? As for example, it was
It is quite clear. I have already mentioned that in the original direction it will be contracted. And if you take some disturbance in the transverse direction, if the magnitude of the vector quantity you resolve into two components, and then you take the root mean square of those two components to get the actual value. Then what is the use of resolving that one? We might be in several cases. That's why you need similar situation, just a moment. Similar situation what we are only defines is, in this case you have to get the mean through taking geometric mean. Okay. Okay, please. I can please. What is asking, what is this implication? The product remains the same. What's physically mean? I think one side is contracted with dilated. Einstein. I am not mentioning X. I am mentioning the longitudinal direction, which means the direction of movement. It can be any of the direction. I am not talking about if you just try to explain that one in terms of the coordinates X, Y, Z, then you can choose that one is X. If you choose it to be Y, there is no harm.
Now, two bands. If we consider the orientation of programs are different, in that case, what we will adopt?
That will be discrete directional cases will be discussed by Dr. Washington. Any more question?
Can I make just one more comment?
Yes, sure.
My comment is this. Again about experiments. You know the convention in the longitudinal direction. If you look at the expression, there is that term inside square root 1 minus b square plus c square. The sometime in the direction which is not along the line of the motion. So when someone says that experimentally it has not been explored, which is not right, it has been explored, and the thing is that order of magnitude of this effect in the transverse and in the longitudinal direction are so similar, though one is contracted, another one is dilated, but the order of magnitude is extremely similar. In that situation, you cannot say that the experimental setup was not sufficient to detect that effect. That's my comment.
Okay, thank you. Okay, thanks. Reaction and longitudinal reaction. That's why we are not worried about making those experiments. Only the Bangladeshis are for the first time playing in these. And can people, those who are experts in this field, carry out or try to think about doing some experiments in this regard? Because we are too old to do the corresponding experiments as well. As you know that carrying out an experiment, it takes a long time. My personal model is set up the experiment in 7 years or so. Do we people want me and Dr. Mashina to do that as well? So we will be giving you some views, and the team which will be left, those who do expect our young generation to carry on. Thank you. Any more questions, please?
One more question, Dr. Shamsuddin.
Yes, okay, this was about back from Rajshahi. We were trying to explain this transverse time beyond decades. Muon has a short lifetime, but cosmic muons are known to travel much longer towards they are detected because they are traveling at a universal speed, so time goes slower for them, and they have a longer half-life. Then would have been the case if they were at rest. So where is how do you define the effect of a transverse time for them for these muons that are in flight?
Then the transverse time is already explained. What you are talking about is actually transverse time they have experimented. What I am saying might be explained on the basis of what they have in their hand. And now we are giving some more clues. And what you people ask me regarding particularly the experiments, I would expect from our young generations, talented like Dr. Shams and other one, I don't remember, may I know your name please?